Alright guys, so for those who missed because of absences, whether it be for testing or sickness or some other reason, or you just want to hear the lecture again to make sure you understand everything, I'm going to try these videos for section 11 so that you guys can make sure you're ready for the quiz on Monday or Tuesday, depending on if you're A day or B day. So really quick review on area of triangles. 1/2 times the base times the height, or base times height divided by 2. Dividing something by 2 is the same as multiplying it by 1/2. Either of those, or both of those, you're splitting it into two pieces. So looking at this first triangle, pretty obvious, the base is 10 and the height is 18. So multiplying 1/2 times the base times the height. Alright, so this is 1/2 times, anytime you're multiplying something by 10, you just add a 0 to the end. Half of 180, or 180 divided by 2, that is 90. Alright, for this next one tricked a lot of people. Think of this as a mountain. If you were here at the base of the mountain, the base is this one, 22. Most people got that. If you were to hike up, you would have hiked 30, I don't know, miles or whatever, 30, but then how high are you? That's if you could theoretically fall straight down from the top of a mountain, you would fall this distance here. So that is the height. That is 15. So for this one, the area is 22, the base times the height, divided by 2. Alright, so putting that into the calculator, 22 times 15, 330, divided by 2, 165. Alright, for this next one, you actually need a little more information than what I gave you here. You need to know that either this is an angle bisector, or you need to know that this side is congruent to that side. Either one of those would be enough information. You need to know that if the base is 16, this side is the same as this side. So if we're splitting 16 into two equal pieces, this is going to be 8, that's going to be 8. Why do we need to know that? Well, we have to solve for the height of this triangle. And this triangle is a right triangle because the height hits the base at a perpendicular angle. So that means it's 90 degrees. That's a right triangle, which we can use Pythagorean theorem for. So if this is 8, this is the hypotenuse, that's 14. We're trying to find B. And we're using a squared plus b squared equals c squared. So we're saying this one's A, that one is C. So A is 8 squared plus B, that's what we're looking for, squared equals 14 squared. Alright, so that's 64 plus b squared equals 14 squared is 196. That to get that out of the way. Okay, we need to solve for B, so subtract 64 from both sides. That cancels out. B squared is equal to, here we have 196 minus 64. It's 132. But we want to know what B is, not B squared. So we need to take the square root of both sides. Square root this side, square root that side. When you have the square root of something that's been squared, you're just left with that something underneath. So B is equal to the square root of 132, which is not a perfect square. So 132, the square root, that is, if we're rounding up to the nearest tenth, it would be 11.5. Okay, so the base, or excuse me, B, the height is 11.5. So now we know the base is 16 and the height is 11.5. So plugging those in, and I'm going to scoot over here and use a little bit of the space. 1/2 times the base is 16 times the height, 11.5. All right, and when you're plugging this into the calculator, you can plug it in any order. You can say 16 times 11.5 times 0.5 or 0.5 times 16. It doesn't matter. If you're multiplying, they can go in any order. So 0.5, that's the same as 1/2, times 16 times 11.5. So that area is 92. All right, so that's 92. This area was 165, and that first area was 90. All right, the next question says, each triangle represents a section of your yard that needs new grass. If grass costs $1.23 per square yard, that should be a comma, which will be the cheapest and how much will it cost? So the cheapest will be the smallest area. That makes sense, right? It's going to take less grass to cover it. So which is the smallest area? This one's the largest, and then this one is the smallest. So how much would that cost? 90 square yards times $1.23 per square yard. So plugging that into the calculator, 90 times $1.23, that would be $110.70. Water really quickly. Sorry. Okay, so why are we reviewing triangles? I thought we were done with triangles. Well, no, triangles are a big part of the polygons that we're working with, because we can break these polygons up into triangles to help us find the different sides. We might be finding the height of the triangle, or maybe we're finding one of those sides, which is, we're going to learn what that special term is. So it's important that we know how to find the area or how to find the missing side of a triangle. All right, so regular polygons are polygons that have congruent sides and congruent angles. So they're all the same side, the sides are all the same length, and the angles are all the same measure. Irregular polygons, they make things complicated for us. They don't have the sides all congruent. At least one of them is a different length. And if one of the sides is a different length, then one of the angles is a different length. All right, so number 1, find and mark the center of the heptagon. It's about right there. We're just going to use our best judgment. Let me get a protractor. If we were to... this is called the circumcenter, and this point is equidistant. E-Q-U-I-D-I-S-T-A-N-T. Equidistant. You might not have heard that word before, but you know equa, that looks like equal, and distant, well, that's like how far something is. So equal distance is what that means. It's equidistant from each vertex. So if we measured from the vertex, those are the points of the polygon, to that circumcenter, it would be the same distance all the way around. And you could measure it for the sake of time. I'm not going to right now. These segments here, going from the vertices, that's the plural of vertex, to the circumcenter, these are called the radius of the polygon. And that one's kind of off just a little bit. All right. The radius of the polygon. So there, it's the radius, that's the radius. So a 7-sided polygon, that's what this one is, that's called a heptagon, H-E-P-T-A, hepta means 7, has 7 radii. They go from this to each of the vertices. So 7 sides, it's going to have 7 vertices, 7 radii. So that is number 4. What we just did, draw a line from the center of the heptagon to one of its vertices. We actually did all 7. This is called the radius of the polygon. And that's the radius. All right, so going back up here, draw a circle outside the heptagon that only touches the vertices of the heptagon. All right, so it's going to look something like this. If the circle goes all the way around and it only touches the vertices. I've got the coffee shakes right now. All right, something like that. Not perfect, but you get the idea. This outside circle is called a circumcircle or a circumscribed circle. Circumscribed circle. It's circumscribed around the polygon. And this one I'm going to do in pink. So it just touches the vertices. That polygon fits into that circle perfectly. Now, next one, number 3, draw a circle that inside that only touches each side of the heptagon at its midpoint. So each side has a midpoint. That's the midpoint. If we draw a circle that is just inside that touches, goes through those points, it's going to look something like this. Again, not perfect, but you get the idea with that one. Okay, this is called an inscribed circle or an incircle. Incircle or an inscribed circle. And it connects all the midpoints of the sides of a polygon. All right, so a lot of vocabulary. Not quite done yet. Next one. All right, so we drew the radius. The plural of that is radii. Now this one says draw all the radii of the heptagon. We did that. When we draw the radii of this heptagon, it results in isosceles triangles. Isosceles triangles are triangles with 2 congruent sides and 2 congruent angles. So this, because it's congruent to this one and congruent to that one, that one, that one, the radius of the polygon, of a regular polygon, never changes. Just like the radius of a circle never changes. It's always the same thing. It doesn't matter where you move that radius, it's always going to be the same thing. So, because this radius is the same as that one, these 2 sides make an isosceles triangle right there. And an isosceles triangle with 2 congruent sides has 2 congruent.
Active shooters, lockdown drill. Lock light out of sight. Code red, active shooter, lockdown drill. Lock light out of sight.
all clear, so we're good to go. All right, so we were talking about the heptagon. We drew the radius. The radius create isosceles triangles. Isosceles have two congruent sides because the radius are the same, and two congruent sides means we have two congruent angles. That one's the same as that one. If we look at this isosceles triangle right here, and we wanted to find the height of that triangle, that would be that line there. That is the apothem. A-P-O-T-H-E-M. The apothem of the triangle. Sorry, my lead broke. Or it fell. Alright, the apothem is the height of the triangle. And because these triangles are all going to be the same, the apothem is the same for all of them. That one and that one. The apothem goes from the midpoint of each segment to the circumcenter. Midpoint to circumcenter. Midpoint to circumcenter. The apothem. One of my classes told me it sounds like I'm trying to say opossum, but I have a lisp. The apothem. Alright, so now, what do we do with this information? It's a lot of vocab. It's important that you understand the relationship they have with each other, especially the radii are always congruent and they make triangles, and the apothem is the height of that triangle. Alright, so now let's look at the hexagons down at the bottom. Unfortunately, this did not print as a regular hexagon, but pretend the top and bottom are the same length as these on the sides, okay? This, if we draw all the radii of this hexagon, if these were the same distance as those, focus on this triangle here, these triangles on the sides. These are equilateral triangles. The hexagon is the only polygon that has equilateral triangles formed inside. All the others have isosceles, equilateral triangles. Only 4 hexagons. Alright, so draw the apothem of one triangle. That's the height. It goes from here to there. And then we use purple for the radii on that heptagon up above. So I'm going to use purple for the radii and the hexagon. Okay, if the radii is 4, that's 4, and that's 4. Because we know these are equilateral triangles, this length is going to be 4 also. Alright, and the apothem hits at a 90-degree angle. It's perpendicular to it, and it cuts this segment in half. So what's on this side is the same as what's on that side. So if the whole thing is 4, this half is going to be 2, that half is going to be 2. And we need to find the height of the triangle or the length of the apothem. It's the same thing. So looking here, I'm going to use this color. We have a right triangle, and if we have a right triangle and we want to solve for a missing side, we can use the Pythagorean theorem. So, a squared plus b squared equals c squared. This is one of the legs, and this is the other leg. They form the 90-degree angle. The hypotenuse is over here opposite that 90-degree angle. So 4 goes in for c, and we square it. 2 goes in for, it can go in for A or B. I'm going to put it in for B. It doesn't matter which one you put it in for. Okay, so now 2 squared is 4. 4 squared is 16. A squared plus 4 equals 16. So we need to solve for A. So let's subtract 4 from both sides. That is a squared equals 12. But we want to know what just a is. So, square root. And then a is equal to the square root of 12. And if we put that in a calculator, That is 3 rounds up to 5. Approximately 3.5. So that is the height of the apothem. All right, the next page. Not going to focus too much on this. Just know that there's not a formula for a shape, finding the area or perimeter of a shape like this. But you can always break it up into shapes that you do know the formulas for. So if you drew a line here and here, that would make this a triangle. You know how to find the area of a triangle. This is a triangle and that's a rectangle. So break it up, find the area of each one of those individually, and then add those pieces together. That would be the area of the whole thing. But I don't want to focus too much on that because I feel like you guys are comfortable with that kind of thing. So we're moving to this. Let's see if we can get it to focus. Focus. Come on. Why won't it focus? Let's see, here's a button. There we go. Okay. All right, mark a central angle in each polygon below and calculate the measure in each. So the central angle is, if you pick two adjacent vertices or consecutive vertices, that just means 2 points or vertices that are right next to each other. So these two are next to each other, consecutive, these two are adjacent, same thing all the way around. I'm just going to pick this one and this one. The central angle is that measure between those. Now, if we were to start here and go all the way around, that's a circle. That's 360 degrees. And these are the radii of this pentagon. Pentagon has 5 sides. The radii, the 5 radii of a 5-sided figure, break it up into 5 triangles. We want to know what this area is of just one of those. So if we were taking 360 degrees, we're splitting it up into, well, however many sides there are to this triangle, so, or this polygon. So 360 divided by n, n is the number of sides, that is the central angle formula. So for this one, 360 divided by 5, that is 72 degrees. Right there, that's 72. And 72 plus 72, if we added those all the way around, it would add up to 360. Or if we took 72 times 5, the opposite of what we did here, we would get 360. All right, next step, what is the measure of each base angle in the isosceles triangle created? So these are the base angles. Now remember, this is an isosceles triangle. 2 congruent sides means you have 2 congruent angles. So these two angles are going to be congruent to one another. So that means if we start with 180 degrees, 180 degrees in a triangle. 72 degrees are used by this angle here. How many degrees are left to work with? 180 minus 72 is 108. I probably should have known that without punching it in the calculator. 108 degrees, but that has to be split between these 2 angles. And it's split equally, so we'd say that is divided by 2. So 108 divided by 2 is 54. So that means that one's 54 degrees, and this one is 54 degrees. So we start with 180, because that's how many degrees in a triangle, and then we subtract, this number here is the central angle that we just found. So the formula for the base angle is 180 minus, the Mathnation book uses the variable c for the central angle, and then divide that by 2. Okay, so let's try with this octagon here. Octagon has 8 sides. Octo means 8. So 360 divided by 8, we need to find the central angle. That is 45 degrees. And if we want to find the base angle, knowing that they're congruent, this triangle starts with 180 degrees. 45 of those are used for the central angle, and then whatever's left, we divide it by 2. So 180 minus the 45 for the central angle gives us 135 degrees left. We split that evenly between these two angles. So 135 divided by 2, 67.5. So that means each of those is 67.5 degrees. All right, for a hexagon. Hexagon has 6 sides. Pick any 2 points that are right next to each other and draw the radii. All right, 360 divided by the number of sides, 6 sides. That one is 60 degrees. And a triangle has 180 degrees, and 60 of them are used in that central angle, and then we divide that to split it equally between these 2 angles. So 180 minus 60 is 120, and we divide that by 2. That gives us 60 degrees. Remember on that first page how we said the hexagon is the only one that creates equilateral triangles? Equilateral triangles have 3 congruent sides and 3 congruent angles. So if you see a hexagon, just know right away, 60, 60, 60. We're going to have an equilateral triangle. All right, now this last one. This is a dodecagon. That means it has 12 sides. So the central angle is 360 divided by 12, which is 30. And then we have, that's 30, let me label that. 180 minus the central angle divided by 2. So 180 minus 30 is 150 divided by 2. And that is 75 degrees. So that means this angle is 75 and that angle is 75. Alright, so now, moving right along, if you're here in class, I have given plenty of time for questions. If you have any questions, send me a message through Remind or send me an email. Alright, the sum of the interior angles. So a while back, we learned about polygons, and we broke them up. Let me get them posted. We broke them up into smaller triangles. So I gave each group a shape, and let's say I gave a pentagon to your group. 1, 2, 3, 4, 5. All right. Some were regular polygons, some were irregular. This one is irregular. If we wanted to know how many interior angles, the total degrees of these 5 angles added together, if we pick one vertex, all right, let's pick this vertex, and from here, draw a segment to all the other vertices. From here to here and here to here, we're just following along on the outside edge along the perimeter of that pentagon. But from here to here and here to that vertex, we've taken this pentagon and we've broken it up into triangles. How many degrees are in each of these triangles? Well, we know triangle has 180 degrees total. So if we wanted to know how many degrees were in the pentagon, we could say 180 times, well, here it is 3. This 5-sided figure makes 3 triangles, or breaks up into 3 triangles. Hopefully the lighting is okay, you can see that. If we had a 6-sided figure, it would break up into 4 triangles. If we had a 7-sided figure, it would break up into 5. So are you noticing a pattern there? However many sides it is, the number of sides, to get how many triangles break up inside it, you just subtract 2. So that is the formula for the sum of the interior angles. And this is kind of a visual or explanation of how or why. 180 degrees times the number of sides minus 2, because a 5-sided figure can be broken up into 3 triangles. So 5 minus 2 is 3. Hopefully that makes sense. Alright, so if we want to know just one interior angle, we would take of a regular polygon. This is only for a regular polygon, which is what we're going to be working with here. We would take this formula, 180 times n minus 2, and divide it by the number of sides. Because if the whole thing has a certain number of degrees, and we want to split them equally, because in a regular polygon, they all are split equally, you divide it by the number of sides that there are. So if this were a regular pentagon, it would be 180 times n minus 2, 5 minus 2, and that's 180 times 3, 540 degrees. Total of all these angles added together. If this were a regular polygon, we could take this number and divide it by 5, and that would be 108. So each of these would be 108 degrees, because we're taking the whole thing and splitting it between the 5 angles, 108 degrees in each. Alright, now the sum of the exterior angles. So a while back when we worked with these before, I gave each of you guys a shape, and I said, okay, continue one of these segments, draw that a little bit past, let me see if I can get it to focus. Okay, there we go. So draw it a little bit past that segment, or past the polygon. This space here, that is the exterior angle. This right there. Inside here, that's the interior angle. Interior means inside. Exterior is outside. Alright, if we cut out all of these exterior angles, which is what we did in that activity, we cut them out, and I said, alright, put them together. Cut them out and put them together. All of the angles added together made a circle. So if we cut out this piece and put it with that piece, that one, it would make a circle. No matter how many sides the polygon had, it always made a circle. So how many degrees are in a circle? 360. The sum of all of the exterior angles added together is 360. If we want to know just one exterior angle, though, we're splitting that between the number of angles that there are in that polygon, 360 divided by n. Alright, so let's work with, let's do some of these examples. And I know you guys hate word problems, because you see them and they look scary and you have to figure out the formulas. You're going to be able to use these notes on your test, and you can just look for the phrases that reference a formula that you're given. So the sum of the interior angles. There's a formula for the sum of the interior angles. It is 180 times n minus 2. So go ahead and write that. And then is, anytime you see is, that means equals. It equals, what does it equal? Well, it's just that, 1,620. How many sides? How many sides does the polygon have? The only variable we have to work here and solve for is n, and that is the variable for the number of sides. So we just have to solve for n. Alright, this is saying 180 times this whole thing. So if we want to solve for n, we have to move this over here to the other side. How do we get that to the other side? It's being multiplied by this whole thing. So we need to do the inverse of that, which is division. Alright, so n minus 2 equals 1,620 divided by 180. That is 9. Alright, but we want to solve for n. Or you could say, what minus 2 equals 9? N is equal to 11. So an 11-sided figure, I don't know what that's called, has interior angles that add up to 1,620 degrees. Okay, the next one exterior angle in a polygon. We have a formula for one exterior angle. 360 divided by n is, so we have the equal sign, equal to 30 degrees. Go ahead and put that 30 over 1, because if we see a fraction, can make this a fraction by just putting it over 1, and if we have to solve for the variable, we can do a little cross multiplying and make that really easy for us. So n times 30 is 30n. 360 times 1, that's 360. Right, but this is 30 times n, and we want to get n by itself. So do the inverse, divide both sides by 30. Alright, 360 divided by 30, that is 12. So how many sides does it have? N is equal to 12. Alright, last one on this page. The sum of the interior angles. Working with this formula again, the sum of interior angles, 180 times n minus 2. And is equals 5 times larger than, okay, so we have 5 times. It's literally saying 5 times. So 5 times larger than, we're just multiplying something by 5. 5 times larger than the sum of the exterior angles. The sum of the exterior angles is always 360. So that's the formula we have to work with. How many sides does the polygon have? We're solving for n again. So let's simplify this piece on the right-hand side. 360 times 5, that is 1,800. And then bring down everything on the left. Okay, we want to solve for n, and just like over here on this first problem, we moved 180 to the other side by dividing it. So divide by 180. Divide by 180. N minus 2 is equal to 1,800 divided by 180. That's just 10. Alright, what minus 2 equals 10? 12. 12 minus 2 equals 10. Okay, hopefully that is making sense and helping you to not be scared of word problems, because you just need to look for the formulas that you know. Look for the description of the wording of the formulas you know. Alright, a few more problems just to practice. The sum of the interior angles, once again, that's 180 times n minus 2, is equals 1,080 degrees. Alright, so divide both sides by 180 because we want to solve for n. How many sides does the polygon have? N minus 2 equals 1080 divided by 180. N is equal, that's equal to 6. But we want to know what n is. N minus 2 equals 6. Well, 8 minus 2 equals 6. So n is equal to 8. One exterior angle in a polygon is equal to 20 degrees. So look back at your formula. One exterior angle, that is 360 divided by n. So 360 divided by n is equal to 20 degrees. So 20 over 1. Alright, we cross multiply. 360 is equal to 20n. But we don't know what just n is, so divide both sides because it's being multiplied here, so we do the inverse. N is equal to 360 divided by 20, 18. So the number of sides in that polygon is 18. Lost my eraser. Okay. Alright. This one, a little bit different. The sum of the interior angles, 180, is, let me finish that formula. 180 times n minus 2 is 2 times larger than the sum of the exterior angles. The sum of the exterior angles is always 360. It's my lunchtime. Okay, now, simplify what's on the right-hand side. 2 times 360 is 720. And then this side is 180 times n minus 2. But we want to solve for n, so let's move 180 to the other side. That cancels out, and n minus 2 is equal to 720 divided by 180 equals 4. Alright, what minus 2 equals 4? Well, that gives us n equals 6. Alright, so I'm going to stop this video here and then do a separate one for, this is the beginning of day 2. So hopefully they'll be broken up into smaller clips. It's still going to be a large clip, but it'll be easier to upload that way. So watch this next one, watch for the next one if you missed Thursday or Friday, depending on if you're